This is a presentation of the Research on Emerging Technology by Samantha Heller for EDF 7489. The purpose of this review is to provide insight into the relationships and treatment effects evidenced in the findings of individual studies, to explain variations in practice, and to build connections between interrelated areas of research. The reason why augmented and virtual reality were chosen as my particular topic of interest is based on the Horizon report that was published in 2017 and made predictions as to what emerging technologies would have the greatest impact on K-16 learning environments over the next 5 years. In light of this report, AR and VR were chosen as the two emerging technologies of focus for this synthesis. Discussing the terminology that you'll hear in this report, I just want to go over the differences between AR and VR and kind of where we are today as it relates to their integration into the educational environment. The border between digital worlds is already beginning to break down, so mixed reality is kind of finding itself at the intersection of both AR and VR. Although mixed reality is not mentioned in this article, it is the next natural step for researchers who are looking at these types of technologies. So for the purposes of this, virtual reality is immersive, and it immerses a user in a digital environment, quite like a video game. Augmented reality places the digital objects over a real-world view, as you can see for that picture in the center there. And then mixed reality overlays and anchors the virtual things in a real-world environment. Those are the three examples that we're going to be looking at today. The beginning of this research synthesis was the literature search that was conducted. As you can see from this diagram, there were 17,201 articles that were found through databases at UCF homepage library website, as well as the Google Scholar databases. In addition, there were other sources that were looked into, individual journals, about 12 journals. I searched those journals specifically individually to look for articles related to this topic. Manual searches were performed on those journals, web searches with Google Scholar and UCF library tools, compiled reference lists that were available online on this topic. A lot of the reference lists from previous meta-analysis and research synthesis were used to find articles that may be relevant to this study. I personally contacted two of the authors who had written about or presented on this topic and asked for further information. Search terms included virtual reality, virtual learning environments, computer-assisted learning, augmented reality, and they were mainly structured to hit on K through 12 environments, and then I expanded that to higher education environments as well. So we came down after the eligibility criteria was put into place, a remaining 9 studies that were used for this particular analysis. 17 studies were coded, and of those 8 were made ineligible, and we ended with 9, or I did. The inclusion criteria, the sample included K through 18 or elementary through graduate student environments. The intervention had to include AR and VR in some capacity. And the outcome measures, they had to have a cognitive learning outcome achievement measure in the article to be included in this analysis. Exclusion, articles that took place in work or healthcare or military settings were excluded. We were just looking at educational environments. Studies that were not in English were also excluded. And studies that were published after 2013, when the last comprehensive meta-analysis was conducted, those were all excluded. So we are looking at studies from 2013 to 2018 in English that take place in educational environments. Those studies also had to include effect sizes and all of the statistical data that was necessary to perform the analysis as well, which led to a lot of exclusions after intercoder reliability was established. 2 coders helped to go through and ensure that the articles that I included in this analysis were appropriate. The methods in the primary research, experimental and quasi-experimental design, simple random and convenient sampling. Knowing that these are not ideal due to the nature of educational settings, control group design is very difficult. And so in many cases, it was limited to higher education settings where they were not required to give the intervention to all students. So I did allow for those studies to be part of the research because they made up a majority of the studies. Coding, studies were coded based on a variety of characteristics that were related to the actual intervention itself. As for the duration of it, the educational level of participants, the content area it was focused on, and the assessment measures were coded for, as were characteristics related to research design. So type of design, sampling method, effect size calculations, and the setting. So the original coding was done by myself, the primary researcher, followed by 2 outside coders to ensure the reliability of the coding form. Questions about local history effects and equating procedures and attrition were also included. In addition to that, there was another coding sheet that I created for more qualitative type information, and it looks kind of like this. And I did that for every study, even those that were excluded. The final studies are listed here along with their effect sizes that were standardized for comparison across studies. Moderator variables examined in this research synthesis include those that you see right here, and they were broken down into various degrees and numerically so that they could be coded. A fixed effects model was rejected because of the variability of treatment effects across studies, and a random effects model was chosen, given that it allowed for the difference in treatment effect from study to study. And I will provide evidence of why that was necessary later on. The hypothesis of homogeneity was rejected because a statistically significant p-value indicated the presence of heterogeneity among the studies. And you can see that from the table provided above, as well as the I-squared value of 96.66%. BAHA, I believe that's what it's called, plot was used to provide information about which studies were actually influencing that overall heterogeneity. While the Q statistics and p-values can provide evidence for it, they do not provide information about which studies are influencing it. So this plot was constructed to illustrate studies that contributed to the overall heterogeneity. And you can see the results there. Study 6 is located in the upper right corner of the graph, indicating it contributes a relatively large portion of the weight. This study was unique in that it was the only one resulting in a negative effect size and also contained the smallest sample size of any of the studies. We did a publication bias funnel plot. Tests for funnel plot symmetry are not recommended when there are less than 10 studies, but 9 was close enough, so 1 was conducted, and no obvious asymmetries were found. And you can see the statistics that support that there. A forest plot was used to look at the overall effect sizes and assess the level of heterogeneity among the different studies. You could see here study 1 has the most weight, and that is probably due or is due to its large sample size of 370 participants. Of the 9 studies included, 6 resulted in statistically significant positive results, 2 were not significant, and 1 result had a significant negative effect. This plot also indicates a large degree of heterogeneity and a greater degree of confidence that the distance and the estimates across the studies cannot exclusively be explained by within variance factors. Effect sizes were also put into a table to be analyzed with study IDs and the upper and lower limits according to 95% confidence intervals, looking at the relationship between AR, VR learning interventions and learning outcomes. For the 9 studies that investigated achievement outcomes for both modes of virtual learning, the effect sizes range from negative 2.365 to positive 2.5313. A random effects model analysis on academic achievement and VR learning interventions resulted in a mean effect size of 0.888, which is classified as large as it's between 0.75 and 1.10. However, the p-value is slightly larger than 0.05, indicating the results were not statistically significant. A mixed factor moderator analysis was used to reveal if there were significant differences in the learning outcomes based on moderators related to the design of the actual intervention. The table indicates there was no statistically significant difference between the studies based on any of these 3 moderators. Data indicate there was also not a significant difference in learning outcomes with regard to effect sizes when controlling for education levels, research design methods, or sample sizes. So here we're looking at the design moderators. However, after analyzing the studies that utilized random sampling and those that did not, a statistically significant difference was found as it relates to random sampling. So those studies that utilized random sampling in the research design reported a negative effect size, indicating that the use of random sampling in the research design had a negative impact on reported effect sizes. So that was about it. So there were various limitations for this research synthesis. One was inclusion criteria. It's possible that a number of studies were excluded for consideration given the criteria that could have provided further insight, so that would be worth looking into. The variability in outcome measures is absolutely a limitation. Quality can vary, and none of the actual assessment questions were provided in the research studies. And every single study had a researcher-created assessment. So the variability was large there, and I was not able to evaluate it. Also, sample populations, I think limiting the samples to specific education levels could provide more detailed insight into how those interventions meet the needs of those specific learners. Finally, in conclusion, the general effect size according to the random effects model of the 9 studies was calculated at 0.888, so it was a large positive effect size for the overall analysis. Another consideration and possible future research implication is that the 3 studies with the largest reported positive effect sizes all included middle school students in their sample population. So further research could determine how this population is different, why virtual learning is more effective in this educational level, or whether it's just an issue of looking at more studies and seeing if what that is actually true. So I am so sorry I could not be there today, and I appreciate you listening to my presentation. Thanks.